So we had y equals, or f of x equals ax plus b over x squared minus c. Girls, the first statement, and even if you got it and I spoke to you and you got the extra quiz grades, please watch, because my work might be a lot smaller than your work, so it's like coaching now, okay? Things that you should react to. If it says symmetric to the y-axis, that's trying to tell me it's even, which will help me in two ways. It'll help me graph later on once y'all were finding those points. So I saw symmetric to y-axis, I knew automatically it was evens. Therefore, f of x had to equal f of negative x. It's a reaction that I have. If they tell you it's odd, f of negative x equals negative f of x, and you can run with that algebraically. So that should be a reaction. If they say in turn, f of x equals f of negative x, above it, write note to self, that means it's even, symmetric to the y-axis. They might give it to you in any form or fashion, but that should trigger in our head something to do. So then I said f of negative x equal to f of x. Y'all understand, I'm sure, what even means, and again, it's a reaction in a coaching situation. That means it doesn't matter if I go this way or this way, I should get the same exact answer if it's evenly dispersed. Now I have the luxury here that my denominators are the same, so that means if they're not the same, then I've got to cross multiply them. You want to be fast and you want to be efficient. You don't want to be fast, you want to be efficient. I was, whoa, those denominators are going to be the same once I square this negative. So what would I have to say about the numerators? They would be the same. So I have negative ax plus b equals ax plus b. And my b's cancel out. I get 2ax is equal to 0. And the only way that can happen is if a is what? 0. So you get a is 0. Or in other words, you could have stopped right here. The only number that would possibly work for it is 0, isn't it? Okay? Once you had that, girls, this is another coaching moment. Go ahead and fill that in. A lot of you didn't have the pleasure of getting A so soon. And it's good if you go on to the second one or the third one. It looked like to me everybody caught on, which was great, the limit statement. You knew as you approached 2 from the right that it was going to infinity somehow. You also were told it was symmetric to the y-axis. And so hopefully you knew you had another asymptote over here to help you with your graph going to infinity, because it's symmetric. You gotta wrap your mind around all of that. If it's gonna have a vertical asymptote, go off to infinity, at 2 and negative 2, I think everybody deduced that c would be 4. Did y'all get that? Alright, so it'd be x plus 2x minus 2. So to make this undefined, you go off to infinity, and to show your work, say it's got to be 0, and that happens when c is, how would I say that? Yeah, you would say x squared minus c is equal to 0. And then I guess you would just say c is equal to 4. So I'm trying to think how I would even write what I found. But we knew c was 4 because of that limit. And then the last thing, f prime of 1 equals negative 2. If you take the derivative of f of x as it is given to you, why it won't scroll up. Okay. It was given to me like this. F of x equals ax plus b over x squared minus c. If you took the derivative of that and filled in 1, listen, because some of you did, you've got a quotient rule, you've got a big mess where you can mess up your signs and stuff like that. But you already know a is 0, okay? Hopefully by then. You know, the symmetric thing. You know a is 0. And so I'm looking for b. So I would say f of 1. Well, first of all, I'm just going to call it b over x squared minus 4. Don't we know that much by now? Use what you know. That's going to help you. All right, so everybody see a is 0, c is 4. So now I have just a little bitty quotient ruler that might even be 1 since there's a constant on the top, that I make it x squared minus 4 to the negative 1. Because there's a constant on the top. But let's do quotient rule. Low, d high, minus high, D low, over low, low. All right, and then everywhere there's an X, what am I going to fill in? 1, so I'm going to put in 1 right here, and I'm going to put in 1 right here. And so I got negative 2b over 9 was equal to, what did they say? Negative 2. And then when you cross multiply, you get b is 9. Once you know b is 9, then they had actually an axis for you to draw on, which is pretty typical, where they have a place for you to draw it. If you want to count by something other than 1s on their axis, if it's not already labeled, you label it. Let them know if you're counting by 2s or 3s. We have vertical asymptotes at 2 and negative 2. If you fill in 0, you get negative 9/4, so negative 2.25 goes like this. And over here, you could fill in a few numbers and find a point or two. And it's great that it's even to symmetric to the y-axis because it gives me this one over here. Okay? One thing that I liked was I was listening to you work is that you would move on to something else and try to find it. Unfortunately, it's a whole lot easier on this problem if you happen to catch A first because it just dissolved to 0 and then you could move on. Okay? All right, now next, okay, before we do the sheet that's coming around, just put it aside for a minute. And let's look at number 5 on the homework for today. Number 5 on today's homework.
Is there another one?
Oh, yeah. Is there only one that you need? Everybody else?
Yep.
So look at number 5 on the homework for today. Okay. I wanted to say a couple of things about this. Some of it, you know, there's kind of a funny thing here that I'll admit every now and then to you. Sometimes I learn things from my students. And at first when I was teaching, I was 21, so about 18-year-olds. So anyway, you know, I needed to be like large and in charge and whatever. But after a few years, I realized I really need to listen to my students because my teachers tended to go, no, just do it my way. And I realized really early on that wasn't always the smartest thing to do as far as a learning environment is concerned. So some of you have heard me talk, if you had me in honors pre-cal, about different ways to learn charts. I usually picked it up from my students, like this is how I do it, this is how I do it. So it'll be a little interesting story in here. So anyway, a container has a shape of an open right circular cone shown in the figure above. The height of the container is 10. By the way, as soon as I get a cone, a conical shape, I'm thinking special triangles. Proportional, similar triangles. That was just not floating around in my head. Watch out for the word diameter. The height of the container is 10, and the diameter was 10, which made the radius 5. And so as this fills up, you can see that it maintains a 5 to 10 ratio, your radius to your height. So it gives you 10r equals 5h. You can use that as you need to. I might use h is equal to 2r, or r is equal to half of h. Everybody okay with that? I prefer this one because it doesn't have a fraction in it, okay? Sometimes the a part will say write the volume in terms of r, or write the volume in terms of h. And then you just got to get rid of one of your variables with substitution, okay? By the way, if they don't ask you to do that, it's a good idea. You're going to be a little aggravated at yourself if you did the product rule here. Do y'all understand what I mean by the product rule? You would get it right, 1/3 pi r squared h, but you would have to say first comes derivative of the second, plus second comes derivative of the first. You gotta always be aware of the product rule. That 1/3 pi is just a number, it's a coefficient. Everybody okay so far? You wanna avoid the product rule at all costs, okay, or the quotient rule. And so I can sub in something that is set in stone that's not gonna change. As long as I have a fact, like the length of a ladder or how far the plane is above me, if that kind of thing is not changing, I can put it in the original, okay? Elena?
If you were to do the product rule, can you take out the 1/3 pi and ignore it, or does it have to?
Can, or a lot of times I'll attach it to the first one,
Okay.
just like 5r squared, you know, so
It's
it's
the
like
same
you
thing,
can
just
take
take
it
it
out
out.
and then go, first comes derivative of the second.
Okay.
All right, so I did the product rule when I was in Cal 1, you know, and then I saw my teacher sub in and think, oh, well, I wish I'd done that. So hopefully I learned the hard way to get it done. If I sub this, I think everybody did okay on the A part. Is everybody okay on A?
Yeah.
Okay. Notice that it wasn't even a calculus question. So you just had to know that ratio. All right, find the rate of change of the volume of water in the container when the height is 5. Is the height in the container always 5? No, so we gotta set this in motion. But before I start, I'm gonna say the volume of the container is 1/3 pi r squared h. And for h, I'm gonna put in 2r. And I get 1/3, 2/3 pi r cubed.
No, we want it in terms of H.
Yes. Okay, so this is where I'm going with this true story that makes me look bad, okay? Years ago, was teaching, they were twins, Brad and Ken Ball, but I can't remember which one. And by the way, Jennifer Blunt dated Brad first, and then went during AP Calculus BC, then they broke up, and she started dating his twin brother Ken. That's all. Anyway.
Roll off.
Yeah, I was like, stop.
One of them.
Okay.
I was like, stop.
No, stop. Anyway.
Were they identical?
They're all my
Were they identical twins?
No, but they looked exactly alike.
That's
One
really
was
creepy.
left-handed and one was right-handed.
That's well, like, I
I'll
think
show
it's
you
like-
pics of them later. Anyway, creepiness aside, Brad and Kim were delightful. And obviously.
Did they get married?
No, Brad ended
That
up
would be
dating
so
a girl
awkward.
named Mandy for a long time that was in love with him. They may still be today, but anyway, he married a girl named Mandy, but not her.
Imagine being
He
like,
married,
we
Ken
should have
married a girl named
married.
Mary. Jennifer married someone else, and she's a whole. Anyway,
You'll
you'll
know
meet
it, I want to
her.
be
I'll have
there.
Jennifer on the slides one day. Let's keep going. Alright, there's lots of Jennifer stories. Okay, anyway, back to what happened. This was like in the 1900s, and I was teaching, and I did this because it's such a nice little substitution. I remember doing it in class, so I was gonna make a big point that day. I'm like, because y'all caught me, and I was gonna go, oh, I'll be so mad at myself when I got to the end, and I would have dv dt with a dr dt. And then I'd look back at the equation, and it would say when h was 5, or how is the height changing. I go, I gotta go back and do it with the other variable. And Brad was like, no you don't. I'm like, yes I do. No you don't. Yes I do. No you don't. He said, well, look back up here. This ratio holds true no matter what. This ratio holds true no matter what. Like right here, if I have 2r is equal to h, then I have 2 dr dt is equal to dh dt. So I don't have to redo this problem. Let me just work it this way. So now I'm going to have dv dt, the change in volume. I'm going to bring my 3 down, and I get 2 pi r squared dr dt. And now it said, well, I forgot what they gave me. Let's see. Water is evaporating.
Where?
It's 5 or 6.
Yeah, ours. Yeah, Carolyn lied, so we ate them all. Excuse you.
What is 5? What are we looking for?
Thanks, guys.
We need the R.
Rate of change of volume. Okay. So I'm looking for dv dt. We know dh dt Y'all listen up. We know DHDT is -3/10 because the water's evaporating. And by the way, if they didn't give us negative, we would need to know that because it's evaporating. And so I know DRDT is -3/20. DRDT is -3/20. So I have to rework the problem. I can go off of that proportion. And I had to stop and think about it when Brad kept saying he's just a super logical person. He's a doctor today. They both are.
I was
But anyway.
wondering if you could do that. I was like,
Yeah, great, good. It didn't even occur to me, and I should have, because that's set in stone. It's not gonna change, that ratio will not change as things change. So you can do that, Emma. So now I'm gonna have dVdt is equal to 2 pi r squared dRdt. And now I need the radius when the height is 5, and I think that's what you were telling me, the radius would be 5 halves.
Yeah, so 25 over 4. Oh, I just put in 25 over 4. Because don't you have to square the radius?
2r is equal to h. So if h is 5, the radius is,
It says 2
5.
r squared.
oh, I should have squared it, thanks.
So I just got 25.
Yeah, I didn't square it. Hey girls, stay with me because when I work a related rate problems in person, it's like one that I really need to talk about, so it's not. Alright, so Grace was pointing out I forgot to square the radius after my great example of how you need to be careful. And then if we get our same answer that if you did it in terms of height, everything should work out. 2 goes into 4 2 times. -75 over 20. What was the answer? 5 goes into this. 5, 4. Is it -15 pi over 8?
yes.
Alright, -15 pi over 8, and always put your units of measurement. This is a dVdt, and so it was cubic, so centimeters cubed per hour. Always put your units of measurement. It's another big deal that I'll be.
Oh. Miss, I just have a quick question about units. It's not about this one, but for 4C, how did you know that it's like radians
It said it in the
per
problem.
hour? It did?
It said it in the problem, I'm pretty sure.
I didn't think
But
so.
no, it said like make sure that it's in radians per hour, but it didn't give you any.
Oh, it
Mine
said in
didn't change
radians
it
per
in
hours.
radians.
Okay, sorry. Never mind.
Alright, so, girls, big deal. You could end up with something that's like, any kind of proportion, when you're doing similar triangles on shadows or cones. You don't actually have to have the letter H in there if it's not convenient. Just point out to the grader that you're using your ratio, and the derivative of that ratio also works, okay? You'll see problems, and I might assign you, there's some in the book, where it says find DRDT, and then later on it asks to find DHDT. I myself worked DRDT, and then when I was in college and I got to the B part, I did it all over again with DHDT, not realizing I could just bank on that proportion. Once I knew DRDT, you see all I had to do was double it to get DHDT, okay? So that proportion is like a big deal. Another thing that just flew through my head, and I wanna make sure I'm telling you, I can't think of what it is right now, just a minute. Oh, this is so super cool, and I don't know if I've shown you this. It comes up on the C part, but you didn't know to be necessarily suspicious about it yet. But look what happens if you have volume of a sphere, or if you have the area of a triangle. A prime is 2 pi r. Girls, isn't that fascinating?
Yeah.
Because I took the derivative and I got the rim of a circle. Isn't that how the area changes as the circumference changes? It's giving it more room to grow.
Wow.
Look at the derivative of this is 4 pi r squared. The surface area of a sphere, the material that would capture that 3D image would have to shrink and grow. Do y'all see what I mean? So it's really cool to look at. All right, now let's go to the C part.
It's the circumference formula.
Whoa.
Yeah, it's really my
Yeah,
one.
that's whatever.
Now C.
That's actually pretty cool.
You're a pig.
This is when I would want you to be very literal. If you read C, if you're kind of, after you read it once or twice, you're like, what do they want me to do? So we're just gonna slow down. The rate of change of volume and the, of water in the container due to evaporation. Okay, and one reason I can't speak is I really need everybody paying attention to me. Sophia and Celine, y'all don't wanna miss this, okay? I'm glad you're talking about that, but you don't wanna miss this. There was a problem years ago, they said the strength of a beam was directly proportional to its,
The beam?
I'm sorry. It was a big pole.
I thought you said B.
B-E-A-M,
B-E-A-M.
like a big pole, okay? The strength of a beam, they said was, I've forgotten the exact formula, but there is one. You know, as the pole gets taller, it gets weaker, but as it gets wider, it gets stronger, okay? So one of those is an inverse proportion, and one of them is a direct proportion. So on here, they said, the rate of change of the volume of the water in the container, I'm being very literal, dV/dt, is directly proportional to the exposed surface area of the water. Okay? And that equals some constant of proportionality. Do y'all see that direct proportion? Okay? If it said inversely proportional to something, I would have to multiply by it up here.
Yeah.
Okay? So direct proportions are the most common. But I've seen them say S is directly proportional to D squared and inversely proportional to R. And then that equals some constant of proportionality, K. All right, now we know that we're looking for the constant of proportionality. And so I'm gonna get dV/dt, which was the one I used earlier. What was it? So I already have one with an R in it. I'm going to use 2/3 pi r cubed. Oh, I'm sorry, dV/dt.
-15/8.
Let's get dV/dt. The volume of the cube, I'm using 2/3 pi r cubed. dV/dt is going to be 2 pi r squared over pi r squared is equal to some constant of proportionality. I'm doing something wrong.
We already solved for dt. It's -15/8.
But that's not, hang on.
Yeah.
That's what we solved for the last. Yeah.
Yeah, we solved for it in part B.
No, but that's after you substituted.
Okay, I know what I did wrong. Sorry. dV/dt was 2 pi r squared dr dt over pi r squared. All right, then we knew dr dt. What did we find for dr dt? A little while ago. Negative. No.
-3/20.
-3 divided by 20.
Negative 3 over 20. So this is -3/10 centimeters per hour.
Yes.
All right, so, I'm sorry, my mistake was kind of a good one for me to make, a bad one for you to make. What I mean, it's good, is it's awesome for you to see me make a mistake and learn from mine, and that way you don't have to learn from yours. I could say I was testing you, because I was so intent on getting this like pi r squared in there that I thought was so cool that I'll talk about in just a minute, that I forgot to finish my related rate problem, okay? B prime is 2 pi r squared dV/dt, a related rate, it would be 2 pi r squared dr dt. Okay? So my mistake was not putting this in here. Now I felt like there was a whole lot of talking going on, so I want to revisit this real quickly. Okay? It said the rate of change of volume is directly proportional to the surface area. They're going to do this to you. As this surface area is coming up or going down, this is evaporating. Can y'all see the surface of the water is a circle? That's where I got the pi r squared for a direct proportion. Then I took the derivative and I got my proportion with my dr dt. Years ago, there was one that was like a trough. All these words that y'all laugh at, but I can't even draw it, but like that animals eat out of, okay?
Yeah, just.
But it said the surface area was rising up And what would the surface area of this chalk be? Even though it comes down to a point, it would be a rectangle as it comes up towards you. Do y'all see what I mean? So they'll do that kind of thing. They'll ask you that, okay? All right, there were, with our last minutes, I'll tell you what to do for homework, our last minute. But there were some hands shooting up while I was going over number 5. I think you had comments, you were really talking about what you tried. Everybody okay with that?
Yeah.
So if you have a proportion, A to B is 4, you can use that proportion if you cross multiply also for its derivatives. You can interchange those. Homework, I hoped we could do this in class together, but I'll let you work too long on that everything. I'll tell you what, so not a bad homework, just do this, okay? Follow the directions on the front page. Make sure you bring a packet with you and we'll do this together next class. It goes fast.
Just the front page.
So, and I'll post that, just the front page, okay? Thank you. So it'll be like the first and last easy homework. Thank you.
Thank you.
Bye, girls.